Hi, everyone. Good morning to those of you in the US, good afternoon in Europe, and good evening in Asia. So appreciate you tuning in for the second day of our hackathon here. And we've got two great presentations. Before we get into them, I want to talk a little bit about hackathon logistics. So this morning, we added a team formation sheet in Discord. So if you are either a hacker still looking for a team, looking for a project, or if you've already got a team, already got a project, please add your details to that sheet. Want to make it easier for all of you to coordinate. I know you're across time zones and working on different schedules. So want to have some asynchronous ways to allow you to meet people. So please do go ahead and add your details there. And then with that, I'm going to bring Michael Fig on, who is going to talk about how you can set up your Agoric environment. So he'll go through some details there. Obviously, he'll be around for questions either during the presentation, or if you have them after, we can definitely address them whenever. So with that, I'm going to bring Michael on.
Hi, everybody. Thank you, Roland. So this is an introduction to how to actually get an Agoric environment started up. We won't go into too much details in terms of code, but we will get into the logistics of how to start things with your software. So as Roland said, we'll be taking questions on YouTube Live and Discord, and he'll surface them to me in the presentation if you want to ask during the presentation. We're going to start with walking through the before using Agoric documentation. This is on the Getting Started guide on the website, the agoric.com documentation website. We're going to start an Agoric client and the chain. So this is just the simulated environment, which allows you to do rapid development without having to actually fire up chain nodes and run a billion different processes. And finally, we'll do a kind of hello world of how to interact from the Agoric client to the chain. First, you're going to need a Unix-like environment. So we then have to install Node.js and finally Yarn 1. For a Unix-like environment, we usually use macOS. Linux is also good. There are just a couple minor details about which Node.js packages you can use. And for Windows, we currently only work with Weasel, the Windows subsystem for Linux. So we hope to support Windows fully at some point, but currently you need to install that Windows subsystem. I don't have instructions for how to do that right now, but if you Google for it, you should be able to find how to do it. So with Node.js, we want to start with version 12.14.1 or higher, and 14x also works well. 13 doesn't for us. It won't work with the test suites we use. Also, you should use the official distribution if you can. The one you install from the nodejs.org website is the one that works best for your platform in general. If you don't want to install it that way, that's okay. So the one trick with the Linux side is you don't want to install the Node.js snap because it can't build add-ons, which we currently rely on. So installing Yarn 1, yes, we want Yarn 1. Usually this is a bundle with the Node.js package that you use. And some things work with Yarn 2, but not every dapp works with Yarn 2. So it's best to just stick with Yarn 1. So I'm just going to show you here the versions that I have installed. I have 12.18.3 and Yarn 1 point something. That's all good. For installing the Agoric SDK, we want to open up a shell, like I've already shown, clone the Agoric SDK from Git, and update the SDK with the latest version. So a shell prompt, you basically need something like bash or zshell should also work. And you want to look for your system's terminal app, just like I have open here. So this is bash that I'm currently running. And you can basically use any directory as your starting point for where to download the code and to install things. So we'll start with cloning the Agoric SDK. You want to run it if you haven't already done it. Otherwise, you can just skip to the next step. So let's look at what that looks like. So I'm going to make a code directory and then change into it and finally do the git clone. So this will take a little bit of time. I'll just fast forward here. And cd into that Agoric SDK directory we just created. And finally, check out the hackathon branch. That's the step here, where we're basically going to check out the hackathon branch. You will need to update this hackathon branch if you're advised by the Agoric team that we need to roll out an upgrade, or if you have an old Agoric SDK before this was done. So the last step you want to do is a git pull after you've checked out the branch. That's the update step. And we're up to date. So next thing we want is to install Agoric CLI with yarn install, yarn build, and then yarn install just installs the libraries that we need. And after you've upgraded or pulled the Git repository, then you want to run a yarn install just to pick up any of the latest dependencies. This can take a little while, so I'm going to fast forward it quite a bit. Notably, building the native packages takes a while. So I'm just fast forwarding it. But this actually does take 65 seconds, as it said. So the yarn build step is just to compile some of the JavaScript files that we have. We're trying to eliminate this so it doesn't take a build anymore, but some packages still need that in the Agoric SDK. So this is what it looks like. Yarn build. I'll just fast forward this one as well. And finally, after you do the yarn install, you only really need to do the yarn build again without installing is after an upgrade, or if you change Zoe's contract facet or the wallet UI. You'll know if you do this because it's a more advanced thing. That's the only time when you actually need to rerun the yarn build to get the effect of the changes. And installing the Agoric CLI, we're going to do this with sudo to install it in the user local bin directory. So link CLI, and this just creates a script for us and populates it. So you can install it in other directories besides user local bin if you're a more advanced user. It's just a matter of putting it somewhere where it's on your path. Finally, we can start to create a dapp project with a simulated chain and play with some JavaScript in the REPL. This is what a dapp project is started with. Now that we've created that Agoric CLI, we can run Agoric init hello. This is how it goes. We'll go back to our code directory. Because Agoric CLI is in the path, we can be in any directory when we do this. Agoric init hello will create a subdirectory containing the dapp. So that's just a couple things. And when we go into the hello directory, we can do an install. This builds the dependencies and links to the existing Agoric SDK. So I'm just going to fast forward past here too. It's going to build some more. It's going to build some packages. And install the linked packages. Okay, that's all good. Finally, we want, after the Agoric install, we want to move on to start a simulated chain. So this is the part that I don't have on recording. I'll just show it to you live. So if we run Agoric start, I'll do a reset just because I want to have a fresh slate. And this basically starts up the Agoric VM, and it'll tell you when it started to run. I'm just going to put this in the background and say Agoric open. Agoric open -- REPL. So when we open the REPL, that actually starts our web browser up with an access to the read eval print loop. This is the interactive command line that allows us to interact with the chain. So up above here, we see the Agoric wallet. And this is all connected. It says testnet currency, but it's currently connected to the simulator chain only. Now in the Agoric CLI, we can essentially run JavaScript commands. So let's take a look at a couple of things we can do. There's a regular console log, and it's just displaying in the little REPL down here. We can look at the home object, which contains a bunch of stuff. This is JSON formatted output, except for these presences. Presences are things like remote objects that you can access through the CLI. So from home, we see that. Let's look at the Agoric object, which is a subset of those services.
Hey, Michael, so we did get one request. I don't know if it's possible to increase font size on any of your windows here, but if possible, do you mind zooming in?
Yeah, I can do that here.
Great, thank you very much.
Okay. So the Agoric on-chain services, an interesting thing here is that we have a price authority. So if we look at agoric.priceAuthority, we see that it's a presence, and we can run a tilde, which is this remote invocation form of the dot operator. So I can, let's run the non-existent help object, and it'll tell us, oh, price authority doesn't have a method help. It has these different methods that we'll introduce later on with how the Chainlink integration fits together. But then we can do something like actually get a quote. Oh, of course I didn't do that right. Anyway, the point is you can wander around these little objects and use them as you would. This is essentially a JavaScript environment, except it's a bit different in that it only has deterministic things. So if I try doing a math.random, I'll just get, sorry, it's not a function. If I try doing date.now, it doesn't return anything. But you can still use most of the APIs that are there. These ones have just been removed because they're non-deterministic and we can't have that on the chain. So this is the wallet. We'll give you a tour of that in a later presentation. I can now go back and answer any questions that there are. This was the quick way of setting up the Agoric environment. So that's the last bit of the REPL, just a basic introduction. And finally, we have hackathon documentation and the actual code for the SDK. So I recommend working through the Getting Started guide. It'll tell you how to do all these things. And this was just a brief overview to show you how that works in real life.
All right, thank you, Michael. And we'll wait a few moments for questions here. We know a lot of you may be watching this on delay or at a future time. So if you do have questions after this presentation, please do ask in Discord, and you can connect with us that way. But we'll wait a few seconds, and if nothing comes in, happy to take questions later.
Great, yeah. So as I said, setting up under Windows takes more effort. The Windows subsystem for Linux makes it harder. But once you set up Wizzle, you'd be able to run a Linux environment and get the command terminal just as we did before. So.
Great. Well, thanks again, Michael. And again, if anyone has questions later on, please do connect with us on Discord. Michael's very active there, and the rest of the team as well. Thanks a bunch.
Thank you.
All right, and next up, so in 15 minutes, we have Kate Sills coming up to take a longer presentation around minting fungible tokens and NFTs. So stay tuned for that. That'll be at noon Eastern Time, 9 a.m. Pacific, and we will see you then. All right, everybody, welcome back. So next up, we've got Kate Sills, who is going to be going over 2 dapps in our system, minting NFTs and dealing with fungible Faucet tokens. So she'll be taking you through the code, talking about how they work and how it works in the Agoric system. So I'm going to bring Kate in now.
Hi, everyone. All right, so let's get started. So today we're going to be talking about 2 different dapps that we have. These are our 2 basic example dapps, and one of them is minting fungible tokens and giving them out freely through a faucet, and the other is minting NFTs and selling them in a store. So they're going to be baseball cards. We're going to sell them in a baseball card store. And I do have a cat, so you may actually witness a special guest star, but hopefully not. But let's go ahead and get started. All right, and currently feel free to ask your questions at any time in the YouTube chat or on Discord. Roland will be breaking in with questions if you guys have them, so feel free to ask them as the talk is going on. And like I said, we're going to be going through our simplest dapps. So the Fungible Faucet dapp is actually the default that you get when you do Agoric init. So you may have seen that already. And that just mints fungible tokens and gives them out. And then there's the card store dapp, which, as I mentioned, it mints non-fungible baseball cards and sells them. So this is what the Fungible Faucet dapp looks like. Basically, the only functionality. Oh, whoops. Let's actually go to the real thing here. Basically, the only functionality is that there's this little button that allows users to mint fungible tokens. And as you can see, it's connected to the wallet. And currently, let's see, oops, it is disconnected from the API server. Let's see if we can fix that. Okay, there we go. It's connected. And let's see if this actually works for us. So we say mint fungible tokens. It says approve the offer in your wallet. So we have this offer here. We accept it, and we have more fungible tokens than when we started. So, and back in the dapp, it says that we've received 1,000 more tokens. So that's the Fungible Faucet dapp. Let's go to the card store. So that is also disconnected. Let's try that. All right, so the only functionality here pretty much is that we can click on a card. So let's buy Raul Chamberlain. All right, we'll be going into how what the origin of all of these names were. It's a pretty fun story, so stick around. But we can click on the card, and that will send an offer to our wallet, which we can approve. And you can see that we have the Raul Chamberlain card now in our wallet. Okay, so that's the basic functionality that we're going to be going through. But there's a lot of little pieces that have been put into the dapps that make this actually work. All right, so if you're following along, we're going to be starting with the Fungible Faucet dapp. So you can either look at the GitHub repository, or locally, if you do Agoric init with any kind of, the My Fungible Faucet is just a dapp name that you can change. If you do that, the default dapp will be the Fungible Faucet dapp. So I'm going to do a brief overview of how all of this is connected. This is kind of at a high level. We'll be going into the actual code that implements this. But as you saw, when I minted that fungible token, so I just clicked on the fungible mint fungible token button, that actually made a call to the backend, to the API server. And that calls creator Faucet make invitation, which makes a call to the contract, which actually makes an invitation with Zoe. So invitations are actually digital assets in and of themselves, but this is how you are able to invite other people to join your contract. So as opposed to Ethereum, where you have contract addresses and you have the addresses of the senders of transactions. On Agoric, everything is in object capabilities. So that means to be able to access something, you have to have a particular object that has particular methods on it. And you have to be able to present that object. So the invitation object here is actually acting as that object capability. So we'll go into more of that later. But we make the invitation with Zoe. It gets sent back to the app server. The app server sends the invitation and the proposed offer to the user's wallet. So that's what showed up in the wallet where I accepted it. So this is really cool because it means that the app server, it's setting everything up for us, but it's still allowing the user to make the decision in their wallet, and it's making a decision in terms of offer safety. So we'll go into that more later as well. But once the user accepts the proposed offer, then the wallet actually makes the offer to Zoe on the user's behalf. And the contract realizes that this offer has been made. It allocates 1,000 tokens to the user, and then Zoe then pays it out to the user's wallet. So then we saw the tokens in our wallet, and if we were to go back to the dapp, we would see that we received a little notification that you've received 1,000 tokens. And you can use these kinds of notifications for various things. I'll show you how all of that is hooked up. All right. So the format of a dapp. So by default, we've set things up so that there's 3 main folders in your dapp that you're going to need to change. There's the contract folder, and this contains your contracts that you deploy to the simulated chain in testnet. That's probably a good important thing to note, is that when you're building against a simulated blockchain, not the actual testnet. There are instructions for deploying to the testnet, and we can also help walk you through that, but it's good to get everything sorted out locally before you try to do that. All right, the second folder is the API folder. This is the code for the backend server. So it's split into on-chain and off-chain code, and we'll go into that later. There's also the UI. This is the front end of your dapp, of course. And a special guest appeared. Sorry about that. So the front end really could be any kind of JavaScript framework. So in the 2 example dapps that I'm going to be showing today, it's just raw JavaScript with Google's Material UI. So, but we also have dapps that use React, that I think someone has built something with Vue. So there's a variety of different ways that you can actually choose to build your front end, and so you should build with whatever you feel most comfortable with. All right, let's see. Okay, so let's actually dig into the Fungible Faucet code. So this is the Fungible Faucet application. As you, if you do a Agoric init and you actually look at the folder, this is what you'll be seeing. So like I said, this is probably very small on your screen, so I'm sorry for that. Increasing the font doesn't seem to actually increase this part of things. But there is a contract folder. That's what we're going to be diving into first. So let's go to contract source and then contract. Let's just start going through this contract. So first, you'll notice that there's this TS check. That's just setting up the TypeScript checking that we have. So we do not use TypeScript, but we do use JS stock that is compatible with TypeScript. And so we're able to have TypeScript checking of the types that we define without it actually being TypeScript. So we import all of the Zoe types as well. And probably the best way to get started with analyzing a contract is going all the way down to the bottom and looking at what gets returned. So there are 3 things that can be returned in any contract. There's the creator facet, the public facet, and then a creator invitation. And all of those are optional. So this particular contract returns a creator facet and a public facet. And what facet means is that it's an object that represents some smaller part of the greater whole. So you can think of this like, let's see, if you have keys to an apartment building or something like that, there's the master keys, And then there's the key for just a particular apartment. And you don't want the person who just wants access to a particular apartment to have access to the whole apartment building, right? So there's kind of like manager keys and more attenuated keys. And so object capabilities kind of work the same way, except we call those smaller authorities facets. So this creator facet, we've set it up so that the creator can make an invitation, and they can also get the issuer of the token that we are going to be creating. And the public facet is also able to get that issuer. So let's take a look into how this invitation is actually being created. So ZCF is what the contract, every contract is given. So every contract has this format where it needs to have a start function, and then it will be passed ZCF, which is the Zoe contract facet. So ZCF has a method called make invitation, and that takes in a function which will act as what we call the offer handler. So when someone makes an offer using this invitation, this code will run. It also takes a description. So this function is really quite simple. All it's doing is it is making an amount. An amount is just a description. It's not actually the minting itself. But then in the next step, it mints that particular amount and allocates it to this particular seat. Then it exits the seat so that the user gets their payout, and we just return the string. So this will be sent through to the offer result for this particular offer. So you might have noticed that there was this ZCF mint, which if you've looked through our ERTP guide will be unfamiliar. So if we were minting with a regular ERTP mint that was remote, we would have to do an await on minting, because any kind of remote call creates a promise that we would have to await. So what we've done is in Zoe, because we want most things that the contract interacts with Zoe for to be synchronous, we made this ZCF mint that has a special interface. So it mints these tokens and then it directly allocates them to the seat. So we have documentation on this. Feel free to ask questions about it, but just so you know, this is a slight difference than the ERTP mint. But all of the digital assets are created exactly the same. The issuers act exactly the same. Everything else is exactly the same. It's just there's a special interface, kind of a wrapper. All right, so I think we've gone through that. So the next thing is the deploy script. So let's see. So most of these deploy scripts are exactly the same. It's doing something very simple. All it is doing is it's taking the code that we just saw, the contract code, it's bundling it, it's installing it on Zoe to create an installation, and then it's making an instance from that. So let me explain a little bit about instances and installations. So rather than like on Ethereum having each contract that is running have its own address, and then if you want to verify the code, then you have to like hash the code and then see if it matches, see if the hash matches, right? What we've done is that you can actually install the code on Zoe, and then that gives you an installation object. And that object you can use, so like, let's say you audit the code, you see that it's associated with this installation object, and then you can just save that in your wallet. And then whenever it comes up again, let's say someone creates a new instantiation of this particular code, you can just check the installation and see if it's the same with object identity. So just triple equals. And this makes it really, really simple to reuse code, and then also to be able to check that the code that you've already audited is being used and not some other code. All right, so we make that installation. And in this case, the deploy code ends with putting all of this information in some configuration files that will be picked up by another deploy script. So let me explain a little bit about the board. So the board is a shared on-chain object that maps objects to strings and strings to objects, and these are just random numbers. So basically what this is doing is allowing you to share things with other entities on the testnet or your simulated chain. And the reason for this is because in an object capability world, everything is private by default. So unlike on Ethereum, where if you have a contract, anyone can hit your contract, and you have to protect yourself from it. You have to check message.sender. You have to set it up so that even if people are hitting all these different endpoints, they're not allowed to get in. On the Agoric platform, everything is private by default. So no one even knows where your contract is to actually hit it unless you give them some kind of access. So what this is doing is making the code for this contract available on the board, so someone else, and including us in a later step, will be able to use it to actually make a contract instance. So let's go directly. Oh, let's first actually look at some tests. So when you're developing your dapp, probably the best thing to do, I know time is scarce in a hackathon, but if you don't want to set yourself up for pain later, probably the best thing to do is to test your contract. And so we provided you with Ava. Ava is the testing framework that we're using, and we provided you with tests of the contract. And so basically, you can see what this is doing. It's installing the contract. It is getting the creator facet that we saw. Alice is making an invitation for Bob. Bob makes an offer using that invitation. He gets a seat. A seat is essentially the position in a contract once you've made an offer. And we saw a seat earlier on the contract side, but this is on the user side. It's essentially the same concept, just with some different methods depending on what side you are on. So Bob is able to use the seat to actually get a payout. And we get the issuer from the contract to be able to check in this test that the payout that Bob gets is 1,000 tokens. Okay, so let's move on to actually deploying this. So we're going to move into the, so we've deployed the code, but now we actually need to create an instance on chain. So let's move to the API folder. We're going to be moving to the deploy scripts there. And so every deploy script is given this promise for home. Home is what you might have seen in Michael's talk that just happened previously. It's what every user is given, and it has a number of different on-chain things that you can use. So it has Zoe, for instance. It has the board, which we just talked about. And what we're going to be doing is we're going to be getting that installation that we put on the board, and we're going to be using it to actually make an instance. And so here we get the creator facet and the public facet. We get the token issuer of the token that we've just created. And we put all of these things on the board such that other people would be able to use them. This is how we make things public. And I think one thing that is important to mention is all of these deploy scripts are ephemeral. So they run in Node.js, but they're not running consistently, and they're not running on-chain. So to actually have something that is running consistently, we need to set up a handler. And let's see, where is that? Here we go. So we need to set up a handler, and we're going to be passing in the creator facet, the board, HTTP, and invitation issuer from Zoe. So we're going to save some more things to our config files, but let's actually go into the handler and see that. So this is a little bit complex. We're working on making it easier, but you can see the things that I just said we are passing in. Those are given here. And this handler responds to a few messages. So it responds to the message, Fungible Faucet send invitation. So I'll show how this is actually called in the UI, but effectively what this is doing is using the creator facet that we saw in the contract code to make an invitation and then send it to a user's wallet. So this deposit facet.receive, the user has put up their, has made public their purse in a way that is a deposit only facet. So no one can look at the balance and no one can withdraw anything, but you can deposit things. And so this is actually sending the invitation straight to the user so that they can have the invitation in their wallet. And it is also sending the data about the offer to the user's wallet. So we'll see how that is handled in the front end. So let's go back to the front end. So under public, under source, and then main, that's where all the magic happens. So again, this is a little bit complex. We're going to be working on making it simpler. But you can see the config files that we saved. We're taking all of that stuff out of here and using it in the front end. Let's actually start with the calls that are made. So once things are connected, what the main thing that we do is that we set it up so that the mint fungible tokens button, on click, it'll actually create an offer that says that that the user will want 1,000 fungible tokens into their token purse, and it will send that message to the handler that we just saw. So let's go back to the handler. So you can see that this case matches what we just saw here. And it will tell the handler about the user's deposit facet for Zoe invitations. Okay, so so there are two pathways that are set up here. One is the wallet, so the dapp UI going to the wallet, and the other is the dapp UI going to the backend, what we just saw. So when we do that, we get a response, and that is handled in this API receive. So that response is send invitation response. We get the offer that is sent back there, and then we do a send to the wallet. So we tell the wallet to add this offer to the list of things that need to be approved by the user. All right. You can see that there's a similar thing for the wallet. So when the wallet sends the UI messages, we handle that here. So the wallet will, for instance, tell us about that deposit facet ID. We save it. The wallet will tell us that our dapp needs approval. So what we do is that there's a dialog that opens. So we open that here. It will tell us about the purses and their current balances. We don't actually use that much in this dapp. But if we did, we would be able to get it and display it from here. It tells us when an offer has been added. So this instructs the user to go, this gives like a little, in Material UI, they call it a snack bar, the little notifications at the bottom of the screen. It tells you to go to the wallet to approve your offer. And you can see once the offer is handled, we close that. And once we get the offer result, so that means once the tokens have been minted and deposited in the user's wallet, then we can give a little snack bar notification for that. Okay. So let's see, and these are just the definitions of the little snack bars. If you were, and again, this is meant to be simple, so if you're dealing with React or something like that, you'll have kind of a much more rigorous way of dealing with state. At this point, we've just defined these and we trigger them as appropriate. Okay, so let's go back. So that's kind of the explanation or exploration of the Fungible Faucet code. Let's actually go into the card store code. So again, you can look at the GitHub repo for this, or locally you can do Agoric init. The only thing is, to use anything other than the default dapp template, you're going to need to use this configuration dapp template with the name of the repo. Okay. So the card store. So this is a little bit more complex, but again, let's start with the contract code. So what this contract is doing is it's minting non-fungible tokens. We're going to do this in the form of baseball cards, and it's creating a contract instance to sell the cards in exchange for some sort of money. So we'll see a little bit of the composability here. So unlike the Fungible Faucet, we're not just minting these things. We're also going to put them into a separate contract entirely to be able to sell them securely. So we're going to be selling them for money, not giving them out. Okay, so here we are actually going to be using the default ERTP language for this. So we're not going to be using the ZCF mint that we saw before. So we're importing make issuer kit from ERTP, and also math kind, this is how you define whether something is a fungible token or non-fungible token and how it should be described. So in this case, we're using math kind string set, which tells you that it's a non-fungible token, and that the descriptions, or how the value of the digital assets is described, will be strings. So the set version of this allows you to have object records. So you might have, like, for instance, if you're selling like event tickets, you might have an object record with properties like event time, event date, who it is, what the seat is, that sort of thing. But for our baseball cards, we're just going to have the names of the players. Okay. So we get an issuer, we get a mint, we get the amount math. Amount math allows us to add and subtract and see whether certain assets are greater than or equal to, without having to care whether the token or the digital assets are fungible or non-fungible or whatever they are. This amount math works over all of those cases. So that's great, because that means if you are building something like Zoe, or if you're building a contract that could buy and sell different things, you just use the amount math and you don't have to handle any of the special cases. It's all predefined for you. All right, so again, probably the best way to start analyzing a contract is to go down to the bottom. We are returning a creator facet here and no public facet. And the creator facet, this particular view, gives us two methods, a sell cards method and a get issuer method. So let's actually look at the sell cards method. So it takes in new card names, which is an array. It takes in a money issuer. So this is our way of specifying what kind of money you want to sell your cards for. So what are you going to get back out of these transactions? And it takes a sell items installation. So I'll get back to that in a second. But it also takes a price per card. So this is an amount in the same brand as the money issuer. That is the price that we will be selling the cards for. Okay, so this sell items installation, like I said earlier, the way that we're able to share and reuse code on the Agoric platform in terms of smart contracts is creating installations and then sharing those. So let's actually take a look at what this sell items contract looks like. And so we're going to be using this installation to make it a fresh instance, but we're not going to be writing the code ourselves. This is actually coming from Agoric SDK. So let's see if we can find that. All right. Okay, so sell items allows you to sell any kind of items for money. And so this is not specific to the baseball cards that we saw earlier. You could sell event tickets, you could sell whatever through the same contract. So this is a reusable component in our system where you don't have to write the code yourself. You don't have to install the code. All you have to do is use the installation that already exists and create an instance from it. In that instance, you will have sole control over. All right, so in this contract, you specify the money and the items brands, and then you save those issuers to Zoe, and you are able to get the amount math for both of those. You are also, in the terms, you should also pass the price per item, so we'll see that in our card store contract in a few minutes. Let's see. Let's go down to the bottom. Okay, so when this contract is instantiated, when we create a new instance from it, we'll be given a creator facet, a creator invitation, and a public facet. So all of the optional things will be present. Okay, so the creator facet, it allows us to sell the items. So we have this offer handler called sell. So let's go up to that. Okay, So sell saves the seller seat, and that is the only thing that it does. So let's take a look at the creator facet. So the creator facet allows us to make invitations for buyers. So we can invite other people to buy our non-fungible tokens or whatever it is that we've put up under the items keyword. It allows the creator to see the available items that are still left. And sorry, more guest stars. It allows the creator to see or to get the items issuer. Okay, and then the public facet. The public facet is very similar. We can see the available items. We can get the items issuer. Okay, so the most important thing here is the buyer seat. So let's go into that. So when we make the buyer invitation, first we check that there has been a seller seat. So the seller has actually put up their items for sale. We check that the items for sale are not empty. And then we make an invitation for the buyer. And that invitation has this offer handler called buy. Okay, so we check that the buyer's proposal has a certain shape. We check that they want the items and they're giving us money. We get the items for sale, and we provide money, the buyer seat provides money. Then we check and see if the wanted items are still for sale. So like I said, what's really special about ERTP as a library is that it doesn't matter whether it's fungible or non-fungible or whatever it is. We can still use the same methods. So here we're asking whether the current items for sale are greater than or equal to the wanted items. And so this works no matter what the kind of items are. Greater than or equal to has been previously defined in the amount math code. All right, so if those items are not for sale, then we fail. And what this does is basically it gives the buyer their money back as a refund, and that's it. And then if we do have the items, then we make sure that the buyer has actually given us enough money to buy the items. So we get the total cost of all the items that they want. We check that the money is greater than the total cost. And then after doing all of those checks, then we reallocate. So we're using this helper called trade that allows us to specify the gains and losses. So in a very declarative manner, it specifies the gains and losses of the different seats. So we can see that the seller seat is gaining the money and the buyer seat is gaining the items. So yeah, Roland?
Hi, Kate. Sorry. So we had a question come in chat, and it was a few minutes ago, but I figured I'd surface it. So the question was from Matt Durkin. Are wallets still associated with a UUID/address?
Let's see. So I think I need some more information. So like an address in terms of like as if they were an actor on Ethereum, or do we know anything more about that?
That's how I take the question, but Matt, feel free to add more if you want.
Okay. No, so Michael Fig is actually probably a good person to ask about the internals of the wallet. But the wallet is essentially it's an object that every user is given on their particular machine. So we have our simulated chain and we have our testnet, and then basically the client machine that people get, we call an ag solo. And a wallet is one of the objects that is available there. It doesn't have any kind of identity that the chain knows about. All it's doing is holding all of these objects that have meaning on the chain for you. So I hope that answers your question.
Great, thanks.
Feel free to ask more.
Yeah, I'll pop back in if there are more. Sorry to derail you here.
No, that was perfect. Yeah, feel free to ask questions as we go along. I'm sure a lot of this will probably not make sense until we've gone over it a couple of times. So feel free to ask more questions as we're going. All right, so we trade so that the seller gets the money and the buyer gets the items. We exit the buyer seat. So that means that they actually, they get their payout from Zoe. And then we check and see if all the items have been sold. If so, we shut down the contract, and we will return to the buyer's offer result, just the default acceptance message, which is the offer has been accepted, and once the contract has been completed, please check your payout. All right, so so that is the sell items contract, which is in Agoric SDK currently, and we are using this as a reusable component. So let's go back to our contract in the dapp store. So we have the sell items installation, which is the contract that we just saw that is installed on Zoe. We take the new card names, we create an amount, we actually mint those cards. So now we have all of the non-fungible tokens that we wanted to create in this payment. Then we make an offer proposal to the sell items contract. But first we actually start the instance here. So we take that installation, we take an issuer keyword. So we are setting up the items to be the non-fungible tokens that we just created in this contract. We're setting up the money to be the money issuer that we specified in the terms. And then and we also set the term price per item, which is the price per card that we passed in the terms here. So we start this instance of the sell items contract. We get these things that we just saw, the creator invitation, the creator facet, the instance, and the public facet. And now we're going to use those. We're going to use the creator invitation here to make an offer to Zoe to that sell items contract with the things that we want to sell. And we will get back a sell items creator seat. So we will return all of these things to the user. This part is a little complex, but we basically are going to make all of the things that were available in the sell items contract available to whoever calls the sell cards method. Okay, so that was a little complex. Let's actually go into the tests for this. I think this will make things a little bit clearer. So let's see. So we are going to be using an imaginary currency called moolah as the money that we want people to give us in order to buy the baseball cards. And we are also going to install the sell items contract from Agoric SDK. This will already be installed for you to use. But here's the installation that I talked about earlier. All right, and we are going to create an instance of the contract that we just saw over here. And we're going to call that, we're going to call the creator facet that we get from that the baseball card seller facet. All right, so the baseball card seller facet has a sell items method, which we just saw. That was, let's see, that was this. And so we're going to pass in our arguments. So all of our card names for this test, our baseball players are just going to be Alice and Bob. We define the money issuer to be moolah. The price per card is going to be 10 moolah, and we are using the sell items installation that we just installed. So we get all of these things back, all the things that we just saw, all the things that we just saw over here. All right. So Alice is going to make an invitation for Bob. So she makes a buyer invitation. She gives it to Bob. Bob is going to buy his own baseball card. So he gets the card issuer, he gets the card math, he looks at the cards for sale, and we check that the cards for sale have the names Alice and Bob. He gets the terms. He makes the amount. So he makes a description of the cards that he wants, using his own name to identify the card that he wants, because the cards are Alice and Bob. He's buying his own card. He makes a proposal, so he gives 10 moolah in exchange for the card that has its own name. And he specifies that, he specifies that the payment that he's going to give is under the money keyword. He mints that payment here. And ordinarily, users are not able to mint their own payments, but this is a test, so we can do this here. Bob would have this in his wallet. He makes that offer, he gets a seat. His payout is going to be his card payout, and Bob obtained is the description of his payment here. So we can see that Bob bought his own baseball cards, and that's enough selling for now. So what we're going to do is that the seller, in this case Alice, is going to exit. She's going to get all of her money, and she's going to get any remaining cards. And the only remaining card is Alice. All right, so that was a lot. We just went through a lot. But going back to this contract, you can see the really cool thing here is that within a Zoe contract, we are able to instantiate other contracts. We're able to make offers as if we were a user, and all of those things we're able to do because of the composability that the Agoric platform has. All right, so let's go and let's see. We have 20 minutes left. Let's go to the back end for this. Or actually, let's first go to the installation. So this deploy script is going to install the sell items contract. It is also going to install the our particular contract. So let's see where that is then. Okay, so the contract that's in contract.js we install. The sell items contract from Agoric SDK we install here, and you can see how you can, this is how you would install something that is just local, something that you install from NPM, you can use require.resolve in this way. So all of our contracts that we have pre-built for you are under Zoe source contracts, and so you can take a look on our GitHub repo under Agoric SDK, see the contracts that we have there. We also have documentation on our website. And you can reuse the contracts like this to actually install them. All right, so we make those things available on the board. We put it in our configuration files as we saw in the first app. And now let's move on to the backend server. So let's see. So in this case, these two dapps are actually connected. So the money issuer that we are going to require to sell our baseball cards is the Fungible Faucet token brand that we saw earlier. So this is the logic of getting that. Let's see. More logic of getting that. So we actually call sell cards with all of these card names, and these card names come from this file. So so this is kind of a fun Easter egg. So I think in the 80s, or at least the story goes, so you guys can check out this tweet for more information. There was a Japanese software engineer who was making a baseball game, and he was required, as per his job, to come up with these names of fake baseball players. So we took those names, and there's another Easter egg that I'll go into later. Yeah, take a look at this tweet, and take a look at the baseball cards. So let's go back to the deploy script. So we have all of those card names. We have our money issuer, we have the sell items installation, and we have the price per card. Let's take a look. Okay, so our price per card is 10 tokens. All right, we make those available on the board. As we said earlier, we launch our handler, and so let's go into that. Our handler is basically the same thing that we've seen before. There's a send invitation case that we handle. And in that case, we make a buyer invitation. We send it to the user's wallet. There's also a get available items call. So the front end is going to use this in order to find out what it needs to display. Oops. So let's go back to that deploy script. So that's the handler that we just saw. And then we save these board IDs to our configuration file. Okay, so let's look at the front end for this. So in main, it's a lot of the things that we've seen before. We have the deposit facet for the user's wallet. in here. We have, let's see. We have code for just handling, just creating the baseball cards. So right now, so if you want to put assets in your front end, the way that we have it right now is that there's just a file called assets, and all of these things get pulled in. You can see that we handle the messages that the wallet receives in the same way. If needed to, we update the cards. So for instance, if someone buys a card, well, it's no longer available on our store. So we need to get the cards available from the backend server, the handler, and then we need to use that to sort through what we actually are going to display. And all of this is meant to be very simple. So if you're using something like React, this will be less ad hoc and more organized. So let's see. So the send invitation response is the same as the Fungible Faucet. So we send a message to the wallet to add the offer, and the user will be able to approve that. The get items response calls what we were just going through to update the cards once it gets the items that are still available, and that is basically it. So one thing that I didn't mention earlier is that every dapp has the ability, once it's approved, to suggest names for the things that it is involved in. So for instance, the installation that we saw earlier for this card store, the wallet can suggest that to the dapp as a pet name. Pet names are basically like in your phone book for your phone. You might have people under mom. You might have someone under, Bob. Those aren't their real legal names. Those are your pet names for them. So the wallet has a collection of installations, instances, issuers, things like that with your pet names for them. And so dapps are able to suggest pet names, but it's up to the user to actually approve those things. So, so we're going to suggest the issuer. We're going to call that the card issuer. And so in our wallet, let's see. So in our wallet, we can see that the card issuer is here under card. So this is a pet name. And here we go. Here's our list of issuers. We can actually go in here and change the pet names. But you can see how it actually gets displayed in the wallet. All right, so that is most of the card store code. Feel free to ask questions. But I just want to go over again some of the composability and features that we saw. So we're able to use the same sell items contract installation as other people are, and we're able to benefit from their audits. So because the contract installation, because the code once it is installed is instantiated in the form of an object, we can just do object comparison to see if it's using the same code as something that we've already audited or someone else has already audited. So we don't have to do something complicated like actually look through all of the code for slight changes or compare hashes or anything like that. Another cool feature is that we can create contract instances inside other contracts. So we don't need to, we don't have to do this from the outside as a user, even though we can. And a contract can act as a user to another contract. So in the sell items contract, what we saw is that it's a contract between sellers and buyers. And what we use the sell items contract as, we took the seller's perspective, but we acted as the seller in our contract that we wrote in order to sell baseball cards specifically. So the sell items contract was generic. We could have sold event tickets. We could have sold whatever it is that we want. But we used that in a very specific way. We reused it. We reused it in terms of using installation that was already installed to sell baseball cards. So that's a really cool feature that we have. All right, so some of the resources you might have seen in an earlier presentation, but our hackathon documentation is up. All of this code is in Agoric SDK in terms of ERTP and Zoe and all of the things that I've talked about. We have a number of contract examples, which are also in Agoric SDK. And then if you are looking, once you've kind of gone through some of these basic demos, if you're looking for more that is specific to oracles, try looking at our price authority API. This is what can be hooked up to the Chainlink oracles. And so in later talks, we'll go through 2 contracts that use this. There's a loan contract, which is kind of like a maker vault in a way. There's a call spread contract, which is a financial instrument that allows you to take a certain position on what the future price is going to be of an underlying asset. And if you're interested in more dapp templates and examples, you can also check out our documentation on that. I think we have maybe 10 of them at this point. And like I said, some of them use React, some of them use Svelte. I think there's a Vue one as well. So if you're interested in different formats and all the different situations that might arise, definitely check that out. We have one for automated market maker with a constant product invariant, so very similar to Uniswap. So check that out. It's called AutoSwap. So that's one of the dapps that we have. And that's it. Thank you so much, guys. Do we have any questions?
Hi, Kate. So there's been a long conversation regarding wallets in chat. I think Dean has taken quite a bit of it. I actually have a question for you. As you were going through building some of the UI out for the baseball card store, for people that are looking at the prize around best user experience, in your mind, are there easy or clear enhancements that we should make or that users should be targeting, or things that you wish that you had?
That's a really, really good question. There are definitely a lot of enhancements that we know that we want to make, and a lot of them are in the wallet. So that is editing the wallet is a bit more complex than editing your own dapp, but we would be happy to help people through that. The wallet is within the Agoric SDK repository, so you would be making a PR against that to be able to edit it or have your own fork of it. I think the things that I would want to see. So as you saw, there's a lot of back and forth between the dapps and the wallet. One thing that we've been working on internally is figuring out how to have wallet functionality safely within the same web page as the dapp. So you might be able to actually import whether it's in the form of an iframe or something like that. Hopefully not an iframe. Hopefully it's simpler than that. But just import a button that says approve dapp within the dapp web page in a way that is entirely safe. And so this is kind of the solution that is very complex, but it's the simplest from a user perspective, right? I mean, just being able, you click something in the web page, it's safe, and you don't have to go to the separate web page, which is your wallet, right? So that takes advantage of some of the things that we've set up under the hood. So we have SES, which is secure ECMAScript, which allows us to run code that we do not trust, or run code that we do trust in an untrusted environment in a way such that those two entities cannot talk to each other, and we can provably ensure that they don't talk to each other. So there's a lot of work that would go into that. So I don't suggest that people try that one first, but we would be happy to help people improve both the wallet and the dapp communications as well.
Great. Yeah, I think for those of you that are looking for, honestly, any of the prizes, but especially UI UX, please do reach out to us. We have ideas. We know areas that we would love to have made more progress on and will eventually, but could use your help. So thanks a bunch, Kate.
Thank you. We'll be around for questions.
Looks like one question just came in from Suhail. Why would the wallet be unsafe in the dapp?
So it's more that the dapp could potentially change things about the wallet. So the threat would be the dapp makes some kind of proposal. In our current implementation, when the dapp makes a proposal, you have to go to your wallet to be able to look at it and approve it. So the threat would be that the dapp somehow changes that proposal to make it look like something that you approve, and it actually takes all of your money. So that's the kind of complex interactions that could happen if you're not careful when you put things in the same web page.
Great. Thanks. We'll give it a few more seconds here in case any other questions come in. Obviously, as we've been saying, we know a lot of you may be watching this asynchronously, so please reach out on Discord if you have questions. We're all manning Discord for the next 2 weeks during the hackathon, so excited to help all of you out. I guess one question just came in from Matt. Dean is addressing it as well. Is the default wallet just another dapp?
So yes, it is. It's in Agoric SDK. It's called, I think it's dapp Swelt wallet or something like that. So it's built in the JavaScript framework Swelt. But you could potentially take that, make it a React wallet, make it a Vue wallet, work with some of the user interaction that we've talked about. So I think there's a lot that could be done there.
Great. And just so those of you watching know, we are also working with existing wallet providers, and potentially more details coming out over the next few months about that. So we'd love to have our own wallet. We also will likely be trying to integrate with existing wallets. Great. Well, I would say thanks, Kate, and as always, please do reach out to us on Discord. Get your team formation details up on the sheet, and we will be in touch. Our next presentations are on Monday.